Sorry guys. Good. So, welcome to talk about Java's hidden performance traps. Those are the slides for you or for your AI. My name is, I should skip this part. My name is Victor, 18 years of coding, Java champion, going right now through AI psychosis, 10 years of training. I am basically going for companies to do workshops for groups of employees. That's what I do for a living. I've been to many domains, and I've given a ton of conference talks that I see you enjoy. Good. And I have a community that I like to meet back home after hours to talk about stuff. And it's a brainstorm of ideas. It's super cool. Be there. There are always more than 100 people there. Good. So this is the official agenda. We should zoom in on a performance issue from tracing to metrics to profiling. And I have a good friend, Joris, who told me, Victor, I have to say, I didn't like your talk yesterday because you didn't tell us what were we doing. And I need to define indeed the context. So we are gathered here today to talk about an API that is slow. Congratulations. That means you have success. Now, why is it slow, right? So that's what we're gonna be hunting today. We're gonna try to trace a performance bottleneck. And I have to repent, first of all, not to forget, yesterday it didn't work out for me to show you an integration with AI, with an MCP to do Eclipse Mat. I will, 30 seconds, it's done. It analyzed all the leaks that I have. And I want to show you just the prompts, that's fun. First prompt, analyze all heap dumps in here. It downloaded all the. I'm not injecting any prompt in your heart right now. No, really. This is I'm an honest guy, right? This, and after that, after it analyzed, it made a little summary after of each of them, right? Tomcat threads holding 20 megabytes pattern. Anonymous. If you've been yesterday, you know. Sublist. Right? Pattern. Sublist noted on the view back. This is basically a workshop for your heart alone. And there are basically, what I might want to point out, heap dumps that this guy downloaded, analyzed with no tool, just by scanning the freaking heap dump, and that's your training. Thank you. Good. Case closed. Now, today, let's start simple. Does anyone in the house see any problem in this code? And I'm not going to hover the yellow underline. IntelliJ knows it. It's a classic story. But do you know? I have a hash set. I remove an element. Can you tell me in terms of complexity, O of what is to remove an element from a set? O of 1, bravo. Because of the hash code, you go to the bucket, remove from the bucket, done. So basically then, if this takes, let's run it. If this takes 14, one second, don't ruin the surprise. Run this, just this, don't you dare. 13 milliseconds, good. How much time do you think this will take? In which moment you say, I know, 13 milliseconds times 100,000 times, right? Wrong. If I try to run them both, you're going to see that the second one runs faster than the first one. How the beep? I need to behave. So, how is it possible to remove 99 and to construct a list of 99,000 elements faster? Do you see this? Faster than removing one element. What the hell is wrong in this picture? Anyone knows? No. I am removing all the elements of this list from the hash set. In 10 milliseconds here, 13 milliseconds here. What is the 3-letter answer to why this happens? JIT, bravo. Who the hell is JIT? Do your homework. Your AI. Am I missing something in here? Because in the first run, the Java JVM wasn't warmed up. It had to load classes, stuff. And by the time it got to the second test, yeehaw, baby, it was all running. No? That's why Java kicks Python. When it gets warmed up, it's super fast, or PHP, right? It's much faster when it gets warmed up. Fun. So that's one first lesson. Don't ever try to benchmark such low numbers without using a professional tool like Java measuring hardness. I'm curious, is anyone in the house in the business of stock trading? Anyone? Stock trading? No one today. Stock trading. In those companies, there is a guy wearing some Metallica t-shirt that knows about Java measuring hardness. Maybe it's you, maybe it's not, I don't know. It's a micro benchmark framework that can test how milliseconds, but microseconds. It's insane. I'm not using it here exactly to prove how stupid I was. Good. Now, fun. But then, what happens if I add one more element to the list? I'm removing not 9999, but 100,000. What would you say? What is the runtime of the Rust? Let's give it a shot. Run. Let's see. And you should already start talking. What the hell happens in here? This is a famous bug in Java, unresolved for 30 years. What the hell happens in there? How many seconds? 11 seconds. God damn it, one more element, and then I'm not doing any magic. It's just what you see in front of you. How is it possible? Right? So it truly is almost impossible to figure out by your own. I mean, you could if you're super smart. I'm not. So I'm going to say Java flight recorder this. I'm going to use actually, you know what? I'm going to go not Java flight recorder. I'm going to do IntelliJ because I'm in IntelliJ here. I'm going to go IntelliJ profiler, and that guy is going to tap into the execution of the program, and he's going to make snapshots of what my threads are going to do every 10 milliseconds, for example. And then I'm going to look right now at the snapshot, at the graph of where time was lost. But the beautiful part of running this or loading a Java flight recording in here is that then you can use your own IntelliJ to traverse the. If you come with a GFR from production, you can load it into here, and then it displays you in your code where the problem is. I hope. 1 second. Why don't I see you? IntelliJ. Oh, I think I need to click on that. Something. Am I? And then CPU samples. This is not the proper one. This one. Yeah. Hot is in here. I know the hot is in here, but where exactly is? And then if you go here, you can see that, if you expand here, you can see that removal turned to call abstract set removal. That's what I'm calling. I'm going to go there. All right. And this is the method that executed just in front of you. Remove all. This remove all is the method in the hash set. Now, this is way too brutal to start to talk. I'm going to lose half of you if I insist more on this. I just want to point out that the fast path went through here. The slow path went to here. The 99,000 went there, and the 100,000 went there. Don't worry, I didn't know it either until I got the profiler on it. So 100,000 elements in the list you're removing gets you into here, and then you end up doing e.remove, e, which is from the list. You are technically doing n times n iterations. You don't get it right now. It's insane to understand it right now. But this is n squared. The other thing is just n. O-n. Boom. Right? How the heck could you get this? Right? You could be thinking the database is slow and you waste 30 and burning CPU to do iterations like a maniac, right? So, welcome to this talk. I need to explain what I just did in here, and I'm gonna go. I want to start with you backwards than I start usually when approaching this. I want to start from the profiling, something that all of you here in the room could benefit from. The second part of the talk, I'm gonna raise the level. We're gonna discuss about metrics and profiling and tracing, which is gonna be must-have for microservice or distributed ecosystems, cloud, fast, fuzz, whatever. But the rest of you guys with the monolith in their hand, with the desktop application, you are gonna benefit from this section, right? So, how long did the method call take? Do you remember high school? Do you remember how we used to? Homework in faculty, did you had to pass a certain test? Your code should run less than? Did you have such homeworks in computer science? You had to write the algorithm to traverse the graph in less than? Was I the only? No? I should talk to my teacher. They had automated tests proving that you actually implemented quicksort and not bubble sort or something. Anyway, I was doing this. Yeehaw! You remember, right? And then you print out. Beautiful. For batch jobs, it actually can work. This stage took this amount. But professionals don't do it like that. Professionals log before and after and do the subtraction. Much better. Much better. Of course, if you do either of these two in real backend code, you're going to just flood the log. If you try this on a very high rate per second, request per second, you're going to just clutter the log. You would pay a lot. In stock trading, they actually told me, we don't afford to log. I was like, what do you mean? We have the infrastructure, we can pull the logs, but we just can't afford it. It could cost us $1 million per month. Something like insane, huh? Cost. Performance overhead logging itself hurts if you do it too much. Oh, did anyone deploy to production with trace enabled? Thank you for being with me. I hope I wasn't the only one. Or you can't edit the library code. You can't really insert this and this line into the library you're using. Right? Or if you have a monolith doesn't have 10,000 lines of code. 10 million lines, now you're talking. Right. Actually, I didn't even met 10 million yet. Let's intercept all the methods we have in Java and log how much it will take. This is going to kill performance itself, right? However, I don't do this often, but I was impressed by these guys, BitDive. It's a commercial product, sorry, 30 minutes, 30 seconds. These guys are bytecode enhancing your code at the Maven build phase. And then they capture the actual executed code graph, the actual executed paths through your code. And then they capture the time it took, the data that came in and out in the REST and the JDBC and API calls, record everything, anonymize, I hope. Good. And then, based on this, they can generate regression tests to prove that whatever your AI slop again. And this is all exposed with love over MCP to your agent. So your agent sees the live code, not just the code. You see my point? The classic question in a monolith, where is the dead code? 20% of old code is estimated to be dead. They never. How do you know? Smart. These are something similar. I like it. So, execution profiling would capture all the thread stacks. Coming back to our story, I'm going to have someone. Do you know what stroboscopic light is? Like when we went to the club, you remember the club? Someone just takes photos every 10 milliseconds, imagine. And then what happens? If you have a code like this, in which F sleeps for 2 seconds for a demo, this sleeps for 4 seconds, and you take a snapshot every second, how many times would you capture F in a stack trace? Don't think too much. 2. 2. And how many times? 4. Good. You get the point. So you're going to have stack traces of the execution, and you're going to have 2 of those, 4 of those. Make sense? And that's called sampling. You're going to be sampling, and then the boxes, the lines we're going to see a bit now, are proportional in size to how many snapshots are fitting in that stack trace, taking care to join whatever is common. Okay? Now, what we're going to do right now, flame graph analysis, and we're going to focus on split points, places in which the execution takes south or north, and you want to see why it forks. Right. In practice, there won't be 2 samples, 4 samples. It will be hundreds, I hope, and it will be a ton of code that you never heard of. It's perfectly normal. ChatGPT is your friend. Right? But the point is to analyze where time is lost. So proportionally, you could say like 30% of my time is spent there. Do I expect that? Do I find that normal? That's how profiling works. By the way, the full stack guys in the room, my respect, JavaScript profiling, same story. Right? Snapshotting what your threads are doing continuously. Good. Oh, this is a dark story. Sampling bias. Since you capture a snapshot at some interval, you might never capture this running. You see the point? And if what you're interested to actually study is this path, you would need a hell of load to actually cause this to appear in your. Do you see it? It's a sampling. It's the same principle as medical studies. You need a large cohort to. Good. In the code, what am I in the plan? Yeah, I want to show you a very fun example. Here, right, I'm gonna show you this. Do you see anything strange in here besides the earthquake? What is this? Anything strange? I mean a REST controller, I should warn you. This appears in a REST endpoint. This. Any feelings about, like your gut feeling, any? Synchronize the part, okay, and combine that with something else to kill us. Synchronize is not bad since Java 25. We love it again. What else causes the drama? Database I/O, bravo. We don't do that. We don't keep hold of a lock global for the singleton, and then we go to the database. Actually, I can do worse. I can call SAP. Yeah. So this is something we don't do. Still, I ran a load test against this thing, and then I captured the recording of this execution, and I loaded it in a tool called GDK Mission Control Free since a while ago, and which says, my friend, you were stupid. Your threads were blocked for a total of 33 seconds. They were blocking by this lone service 520 times. So if you just click here, this is a very old tool, but it says here lock instances, and if you click on these threads, do you smell here Tomcat? Yeah, a mad Tomcat, which is there, blocked. I have the blocked effect. Blocked. You knew what came. Blocked where? If you scroll thread run, do filter, where am I? Get lone status. There you go. This thing over here is just blocked. This is another flame graph, but it's displayed. This is called ice something. Let's put it flame graph like we were seeing before. Now we're talking. So this get lone status is where your threads are blocked into that lock. Of course, I couldn't help myself yesterday, and I asked yo Claude, can you please look at the? A second. Is this one? Or is this one? This one. 1 second. And it says here, GFR analysis record, right? Key finding. You were stupid. Severe, you mother. Severe. Fifth. With no Java mission control. I initially tried to hack into GMS. No, you don't need that. AI can just figure it out by itself. But in the process of figuring out, it struggled a bit. And at the end, I asked, like a good citizen, did you use the GFR skill? Anything you learned from this experiment, please remember to write back in the skill in this repo and push it to the main. To save me tokens next time, please, and time. This is what good citizens do with their AI. They teach their AI. Anyway, you're going to hear more and more about these days. Custom agents, self-learning, all sorts of madness. But it figured the point. But this tool also pointed out how stupid I was, so no problem. Fixed. The fun fact, though, is that this GFR that we are talking about over here, this GFR actually is you can record in production because it has a very, 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 very low overhead. And then you just load the GFR in here, you say open, and you just get the file from production here. And the file from production doesn't contain sensitive data. Still, there is a tool you can use to anonymize the contents of the GFR when you bring it. I've actually worked with clients that brought from very sensitive defense infrastructure, they brought GFRs to study. It's doable. So it's doable. Good. Lone service. Now let's go more real. Let's go more Spring a bit on this. I want a more elaborate example to study this whole thing in more context. So I'm going to fire this load test. I'm using Gatling here as opposed to JMeter yesterday. Gatling over here is a DSL. To read it once, it says fired against this get 23 requests in a closed world model in which all the 23 threads are looping in an infinite loop for exactly 8 seconds, firing like maniacs, request after request after request after. This is exactly the JMeter behavior, right? The Gatling team brags about another madness called inject open. I will let you discover. It's much more close to what real life looks like. But the point is, I exert 23 continuous requests on my application. It's a constant load. It's an easy lab experiment, right? Against out 8080. That being said, fire in the hole. I do see an issue. One moment. I wanted to show you the flame graph in a new tool. So I will have to go to, where are you? Come on, edit configurations. My application only Lotus. That's it. That's silly. I had this profiled application I can run, but not only run. Yeah, let's run it once. But then I want to edit the configuration. Somehow I lost. That's good for you because you're going to see what I'm doing. VM option. And I'm going to go there into my folder here, into workspace. And I have a friend. I use this tool. Don't use it in production, I warn you. It's a didactic tool. It's called GlowRoot. It's a very easy to set up. You don't need to do anything, but just take the path for this and then add it with -java agent. This. Done. Run. Let's try again. The profiled application should print at the beginning that, hey, I've opened GlowRoot at port 4000. There you go. Good. Now, once this is on, I'm going to fire the load test again. GlowRoot is a little tool, very nice tool, localhost 4000. Come on, GlowRoot. Where are you? Are you there? Profiled application says that 8080. Okay, die. Let's try again. Profiled app. Don't you want a script that kills port 8080, whatever is there? 1 minute with Claude. Cannot invoke performance profiling entity get loan because loan is null. Is this me? Let's try again. 4000. This looks good, but then let's go to load test and let's run the load. So what this guy is doing is collecting the requests received by the application and very fun, classifies them by the path they've entered, right? The URL. And then if you go to, it shows some very cool things here, the typical mistakes we do. I'm gonna skip that. And here you get a beautiful flame graph. Can you now see why it's called the flame graph? Yeah, is it obvious, right? So this shows where time is lost in an application. Now, as any stack trace, I'm going to zoom a bit. This is a tricky part because you can't read, I know. If you look at it a bit, it looks just like your your stack trace, right? Looks just like a stack trace. Like any good stack trace, we read it from bottom to up. So once upon a time, there was Tomcat. If you scroll your eyes, you're going to find Coyote. Anyway, you're going to find Spring is in the house, of course, and then Spring security, etc. And at some point, there is nothing wrong in this part because there is no split point. There is no place in which the execution takes two paths and I have to understand why it takes one path. No, not yet. But as I scroll up, what is this, my friend? Was ist das? Let's zoom in. What is this? Who is GDPR aspect? Are you feeling anxious right now? GDPR is in the house. GDPR aspect? What the? Who the? You know who? The guy that left. Always the guy that left. Nowadays, AI. Who the? Now, this in particular has some potential. I've extracted this from a code of a client. It is interesting. It is smart. The general idea, I don't want to spend here all day, but the general idea is that if there is a field which is marked with visible for admin, that field gets nulled if you are not admin. You see the point? You're like post-filtering. You're throwing DTO, and this aspect is going to null your fields. Perfect. Now, the fun fact is that the DTO I'm actually asking is this. What difference do you see? Let me just put the screen. Come on. There is no annotation like this, correct? So this is the DTO I am actually asking for. And there is no visible foreign here. That's one observation. Now let's go to the GDPR aspect and look here. I would like to ask you guys this. Look, but I forgot to show you something. If you are curious why this loses 16% of your time by being accountable for 1,800 samples, do you remember stroboscopic light? In 1,800, there was a guy behind you. Like he was wiring me, like, I was like, what are you doing over there? Good. So click. If I click there, I'm gonna see that. Wait a second. What do you think happens here? Sorry? You wish. No. No, it's a call, right? It's an HTTP call to a remote server. It's an API call, it's an aspect. Oh my God.
May I have your attention? Oh, baby, baby. I did it again.
Okay, so the point is, like what? I have the perfect fix for this.
Brother,
Half of
What's
you don't know
that?
what an aspect is. And this
what's that,
aspect
brother?
calls network. Who approved this? Claude. Who approved this? Oh God! But no, every time you see such monsters, there is history behind it. At the beginning, the role of the user was retrieved from the Oracle. Then we changed the user key cloak came and someone did that and forgot about it didn't really look much. And now we have the fetch user role here. But the fun fact is that this if checks whether there are fields annotated with the annotation, correct? And this happens after, bravo, how fast you are. People are like, what are you trying to say? What is the fix, my friends? Exactly. Freaking done. Oh my God, do you see this? This is not a proper fix. The proper fix would be to extract from GVT the role, somehow think of caching something, not just for the network. Are we good? Save, load. What do I expect to see? When I restart, I expect this section that split my execution in two to disappear. This has to go to die. This has to die. And this line should go basically up to, make sense? Visually, what I expect to see. Right, let's go to the graph again. Where is my GDPR aspect? UB, where are you? GDP, You are sitting there quiet, are you? Yes, master. No splitting point this time, master. Goodbye. Are we good? Clear. You can see the effect. The interesting enough, it's very hard to tell the milliseconds you've gained. You need to look at the actual output at you can only see proportionally where time was lost, and if something is outrageous, like, blah, then you investigate, what the hell is going on in there? So you have to come with some assumptions to the code, right? Good. And I want to ask you guys, if you suspect, look, I'm going to then scroll up and look, what is still losing my time? And I see that I have here 65%. I will click to see it larger. Does what? Can you guess what this part is doing? He's too fast. He said, getting a database connection. She just had it in the break before. We have it in production. This over here is acquiring a connection from the JDBC connection pool in order to hit the database. Fun. Good. But that's not all. I will ask you in a moment why do you think that happens, but I want to show you something else which is quite fun. Action support. Now, let's fix that. In the loan service over here, loan service, if you go to the top, this is the method. The method is called getLoanApplication. Can you tell me what is wrong in this picture? Oops. Sorry, louder. Who the heck, Claude? Who the heck put? No, Claude wouldn't put it. That's a haiku. I don't know who this is. Transactional placed on a class. You know how I call this? Junior style. I heard we do banking in here, so let's put transactional on the top. We are transactional. We do transactions over here. Right? Let's be consistent. And then that transaction placed on the method propagates on the class, propagates on all the methods. So it's just like if you would have put it here, which is plain stupid, because this is a find. You don't need transactions to read. Are we good? Sanity check. We don't transact reads. Good. Do you have something to say about this? Come on afterwards. There is you can argue, but no, you don't. Good. So that is gone. Save, deploy, run. The transaction as per support that stole my time should go away, because I will get the transaction, the connection only for the duration of this method. I will not keep it for the duration of the API call. So in very brief, what was just happening is that I had transactional on a method that was also doing a network call. This is one of the non-obvious situations. You have an API call in a transactional method. That is a famous mistake in Spring, what you can do often. For the duration of this API call, you are keeping hold of the connection and calling SAP, comment API client. Dying there for 1 second, 1 minute, whatever it takes to. And does anyone know how many connections we have maximum in Spring by default? 10. So you just took 10% of the capacity to hit the database for 1 second. This is a denial of service in the making. 10 requests, you're dead. And I have the perfect effect for being dead. Flat, dead, perfect. Now, coming forward, what you can do, we've deployed again. We should look into the log to see how this looks again. Looks better. I'm not going to spend much more time than pointing to line 31. I want to ask you guys if you expect that line 31 eats 14% of your time. String concatenation. So what happens when you string concatenate? Like an animal. And animals use Lombok, use data on entities to define what an animal is. No hard feelings. I was an animal. I sometimes still am an animal. In my demos, I am an animal. Oh God, this generates toString. And what does toString do? And let's scroll the flame graph for extra fun. So why would this 14%? And what do you see over here? Who the hell?
Who let the dogs out?
Let the database in.
Who let the dogs out? Who let the dogs
Oh God, this is so embarrassing. I'm sorry.
let the dogs out?
Do not generate toString if you have collections in the God, don't do that. That would trigger lazy load junior style. Okay, sorry. This is too funny. But there is another mistake. IntelliJ says, are you this stupid? This is a trace. You don't even log the trace. Why are you computing the string? And you say, I'm sorry. Click. Done. Both of these solutions would fix the issue, but I wanted to show both correct solutions. Are we good? All good? Fun. Just by flame graphing, right? Just by flame graphing. Guys, I'm trying hard to make it fun for you, but this is not fun. This is hard to understand that Hikari connection. How would I know 10? I asked AI. Okay, but it's still hard, right? So I want to show you a couple of other situations I've had in the clients. After this workshop, they called me back and said, Victor, thank you. Why? What was the problem? And they said, Victor, we had the Mongo export. Took 6 days if we let it finish. What the hell? We were concerned about using an obscure library, quite sexy if I ask me, called JSON-L. Whatever that is. Basically a JSON line and then enter. Interesting. It's how, you remember those payment XML files of 2 gigs? They are JSON-L now. Anyway, the point is they were looking into that library where in fact Profiler showed that they were using Mongo item reader. So they basically just asked online, is that okay? And then they saw that that actually opened a new connection for every page of 10 items, re-bombarding the Mongo with, instead of streaming. They switched it to cursor item reader, 3 minutes. These guys were importing in Microsoft Sukili server. They had a batch inserting 11,000 rows in 1 second, all good, fun. 5,000 rows in 100 seconds. It's half, but wait the hell. What they did was very smart. They compared the flame graph of one import with the flame graph of the other import. And they saw that the slow one was not using do insert bulk. The fast one was using it. The slow one didn't. Googling it up a bit showed that if they try to insert a date column in a bulk insert, Microsoft Sukili server fails miserably. Inserting row by row by row by row. Again, after the fix, 1 second. So these are like places in... There is another one, Kafka streams. Kafka streams, they had a processor doing API calls. The team was investigating the latency of the API they were calling. But the problem was, everything was fast. The problem was that the latency wasn't lost in Java, was in C++ code. A place where, unfortunately, Java Flight Recorder cannot see. So they've used another profiler called async profiler. Let's say this is the bigger brother, the bit more heavy, but much more powerful. Basically, they saw that the Kafka send was blocking in RocksDB native code. The solution was to upgrade their Kafka clients, right? But they couldn't have found this with GFR alone or with just guessing. You can't, because it's a native code under which there is a problem, right? Oh, and GFR records virtual threads already. It captures the stack traces as well. So there are basically 3 profilers in Java. There are 3 profilers, GFR, and async profiler. Anyway, they see into libraries like we saw. They see virtual threads. They require tons of samples for accuracy so that you either reduce the sampling rate, you increase the rate to snapshot faster, or you have a lot of load tests on it, or you deploy it in production. Don't laugh. I have clients keeping from the 3 instances, one of them tapped with GFR in his butt in production, continuously recording, and they are just feeding that way to AI. Yo, AI, everything fine? Huh? So it's a healthy way. It's 5% loss, they say. Right? It's very, very, very highly tuned inside the GVM, super tuned. They've spent tons of brains for decades to make this super efficient, byte code, super efficient. Right? But it has some problems. Doesn't see into native code, and it can be, this is very hard. I'm going to ruin your life if you explain this article. If you are in the micro-tuning world, click this article. And if you are, async profiler. Oh, and whatever you do, none of these can follow you into multi-threads. If you spawn threads, you're dead. You cannot see what your child did. You can only see you are waiting for them. God, hear me out. Let Oracle release structured concurrency in September, despite what happened 2 days ago. Please, God, let them release structured concurrency to us, because the virtual threads that we will fork will remember their parent. And I will be able to use GFR to see what my children did. You can actually, this is coming, it's already there. Agent can, my cloud can go into this. Right? Good, so that was the Java Flight recording part, the stuff that is dark and you probably missed it. There are 200 chapters in 5 minutes. I can't really do them all. That's why I started with that. So tell me this, do you want to talk about metrics Or tracing in 5 minutes. Who wants metrics? I'm going to have a slide for you to guess what you think is wrong about this picture, about this metric. Who wants tracing? Oh, I didn't see this coming, honestly. I did not expect this. So once upon a time, a request came into a system, which called another system, which called C and then messaged D, and is waiting for a response on another queue, if you know that pattern. D calls E, and E is waiting for a database call. And in this madness, the client is feeling lonely. It's feeling sad with errors and latency. So how do you trace the request? First things first. The concept of a trace ID is a number that is assigned at the entry in your ecosystem, usually in the API gateway, the first system that sees. Sometimes even the single-page JavaScript adds this, and it propagates it into your system. A calls B, B calls C, C calls D. Now, this trace ID generated at the beginning is propagated over headers. Who knew this already? Headers come in. I'm boring you. Good. So inside the system, it propagates magically using thread local, and we will see in a second. And now the battle begins. Should I? How to phrase this? No, ignore this line. It doesn't fit here. No, the battle is here first. Thread local. How do I propagate the tracing from the entry in the outbound calls in my code, not to lose them? If you ever do multi-threading and you spawn threads, or you use, God damn it, my condolences, reactive programming, you have to click these links there to understand how you can propagate the things into the. It's very magic in reactive, especially to propagate from reactor context into the thread local to execute the lambda, and after the thread local, put it back in reactor context. It's insane, but it's done. The reactor has released new versions that supports this quite nicely. Scope values, God, please hear me out. Good. Now, the dark stories. Spring Boot 2 versus Spring Boot 3. Let the battle begin. They speak different headers. Great words, but things are now settled since we have a standard, OpenTelemetry, and we have our beloved zero-code agent that you plug into whatever you have back home, meaning, what the heck is Obi? Go, .NET, Python, Java, JavaScript. Good. And then the requests that propagate among all of these are automatically decorated in and out with all the. Are we good? You knew this. You know this? Almost. Not all of you. Not all of you. So there is an agent you can plug into your GVM that will automatically pick from the incoming requests what you have to pick, propagate it through these magic things into the outbound. So what this guy is actually doing, it is, where are the framework supported libraries? If your framework is not here, you are living in the past. Spring. So in this large list, all of these things that you, Hibernate reactive, I didn't really? When did that appear? Anyway, Letuce, log, everything you know is here. And what they do, they recognize these classes in your project, and they bytecode instrument them when you load the Java agent. All you have to do is to register a Java agent. I'm going to show you. Can I show you an example about this? I'm going to save time. No. But based on these agents stuck in your GVM, these agents are recording and are propagating a trace ID through your code. Then also the agent hacks into logback to print the trace ID in your log. You know the drill, right? This is fundamental to know that the request that came to order service propagated into catalog service. You know this by the same trace ID. This is what saves our lives when we debug problems in distributed systems. Huh? And then we kindly shuffle all these logs into a log stash, Kibana, whatever, Elasticsearch, in which then we search them. Huh? And we can see correlated logs. Who does this already? Half of you. Perfect. Now, this is about propagating traces and aggregating logs. Now, there is another thing you can do with this, which is to report the time you spent for a given trace to an OTel collector, OpenTelemetry collector. But this has some issues. How many spans of time would you report to that guy? If you report the time spent for every single request, that's gonna cost a lot. So you're going to have a proportion of, which gets us in the same problems of sampling issues. You might miss that which matters. But you might say for payment, I want 100% sampling rate. Or for the early canard, for the new release version, I want 100% sampling. You see the point? You can scale. But something I did not know, and GPT taught me, you can do tail sampling. You can send everything to the collector and let the collector decide whether to log it or not, and all the errors and slow traces are going to be remembered, stored in the database. The rest, flushed. Smart, very smart. And I had more. This is exactly the output that I captured yesterday, I think, from my two systems talking to each other. You can see my system getting into the other system, and then the same doing a select in database. And the time spent are here. I had an exercise for you, but I can't do it. It's enough. I will be kicked out of here. So, yeah, sorry. So I hope this was useful. I want to finish with one slide only about what did we learn. Do not start profiling first. Go first to reproduce it, trace it, see where the time is spent, look at the metrics of that system, and only then take the bazooka out, in this order. And then you measure what words putting in there for what you gain. Right? MCP over elastic, MCP over. Yes, and I was able to ask today, sorry for being over time, I'm going to be punished. This. My agent knows to pick from Grafana MCP that this trace actually composed of this. The picture I showed you in Grafana is extracted automatically. This is heaven. You just say, show me the last trace. Show me the traces over. So, do you know to write PromQL? I don't know to write PromQL, but I have a friend that does. So, that being said, I thank you all for your attention, and yeah, have a great conference. Woo!